Alright, looks like we're live. What day is today? It is Tuesday, which is an unusual day for me to stream, but I was, what do I usually do on Tuesday? I guess I usually teach my brother on Tuesday. But he was busy today, so I'm streaming instead. It is April 23rd, 2019. What have I done since last stream? Not much, probably. Let's see. Check my pull requests. Nothing. I reverted a thing that was no longer necessary. That's all I've done since last stream. But yeah, the plan for today is to try and work on this thing in this library, which, if my German pronunciation is at all close to correct, it's pronounced werkzeug. So sorry. Which is apparently work stuff in German. But what werkzeug does is it's the like base framework that Flask is based on. And noticed a memory leak in one of our services at Lyft, and I tracked it down to this minimal reproduction, which causes memory to go very much up and to the right. And we have a service in production that happens to exercise basic like code that looks basically like this. Yeah, so I hope to fix this during this. I did a little bit of investigation beforehand, so I kind of know where the code is rooted at, and we'll go into that. Oh, actually, I just got... I just got a message about a little thing in PyUpgrade, so maybe we'll look at that too if we get time. Let me just copy the link so I can show you what I'm looking at, because you guys have no idea what I'm looking at. There's a minor bug in PyUpgrade in Py3.6 mode where this mini language format string with indexes here isn't handled properly, and so we need to make that happen. But didn't fix this part. But yeah, maybe we'll look at this later too as well, because it should be pretty easy. The trick here is like for these special indexes, basically just need to split on here and reformat these as string literals, and that'll get those working correctly. My voice is also a little bit weird today. I went to karaoke again last night and sang my lungs out, so that's if I sound weird, that's why. But yeah, we might get to this later, but let's get started on this. So I'm going to show you like how I reduce this memory bug, or this bug, and then I'm going to try and figure out how to fix it. Unfortunately, the code is super complicated, so we'll see if I can actually get something working. Oh, I guess I should start my chatbot first. So I forgot about that. Just quality streamer right here. Boy.py. I was messing with the bot a little bit off stream to try and make this command work, but I didn't get it working, so right now there's a little placeholder. I noticed that someone else subscribed to me, and I wasn't sure who it was. I have an idea, but I wanted to write a command so that I could demonstrate that. But I got to the point where it was like OAuth scopes and juggling tokens, and because the chatbot is a different account than my account, so like the tokens are for the wrong user, and like all this stuff that I just eventually was like, I'm gonna figure this out some other day. I can't do it in the 15 minutes before the stream, so I'm gonna hack out at a different time. But that was my goal before stream. I didn't quite get it working, so I don't know who the other subscribers are, but anyway, thank you guys for subscribing. But yeah, let's clone this and get working on this. Palettes, werkzeug. Oh, they're using pre-commit. Cool. Pleasant surprise whenever I see that. What are they using pre-commit for, though? Oh, look, there's my name. I did it. I did it, Mom. I'm in the werkzeug repo. It looks like reordering imports, and black, and flake 8. And some white space fixing. Cool. Minus these files. Seems about right. Cool, so wonder what they use for a test suite. I can show you like kind of the setup that I had for my little test harness, and I'll go into like how I narrowed this down as well, because that like it's not super obvious how I got to this like 2 lines of code here, but let's see. We can start with their Travis file. It looks like they're using talk, so we can go to talks next, and it's PyTest. Yay! That should be pretty easy to go through. So let's just get their tests running first. The install requests. Well, that seems promising. That test is kind of slow. Okay, cool. But we have the test suite working, so we can start iterating from there. Okay, so looking at this example, I can just kind of show you what it does when you run it. Stick that in a file and open up top. And I'm going to sort by memory percentage, because we'll see it shoot up pretty quickly. So it starts down here using this much memory, and you can see it's like doubling every second or so. I'm gonna cancel that before it uses up all of my memory, but you can see that it's basically running away. And I did a little bit of debugging into this. So the thing in production looks less like this. It mostly looks like load from config file, which does some stuff. And the app in question is a service that powers vanity redirects for Lyft. So you can go to lyft.com/ I don't know, something. I don't quite remember. And this service handles it by using werkzeug mappers and rules. So load a bunch of URLs and destinations. So like it did that. Then it sets up a rules mapping, and like for config and configurations, rules.append, rule thing, and then it does return map rules, something like this. And while I was narrowing this down to a minimal reproduction, I basically just changed this to rules equals giant list of current production rules, which I grabbed out of our configuration file. And this was like 200 things. And there were a bunch of them that were like, I don't know, whatever. Xdrive or I don't, whatever, something. And then like foo/string path. I don't know. There were a bunch of them, but there were about 200 of them. And I noticed that with this simple setup, I was still reproducing the bug. And then I tried a couple of things. The first thing that I tried was just return rules, so taking map out of the situation. And that showed that the memory leak was dependent on map, because this was not showing the... oh, I guess it was not return rules. Return rule... So this showed the memory leak, but this did not. So I knew that it was related to map and not a result of the construction of rule that was causing the memory leak. So we kept this code, and then I looked at the list of rules, and we had like 100 of them that looked like this, and there were only 2 of them that looked like this, like had parameters in them. And so my initial hunch was that the parameters were what was causing it, so I shrunk my list down from 100 to 5, just the ones that had, like, the first 5 in the list, because the first one that had a parameter was like the 5th one in the list, so it was pretty easy to still include that one. And the memory leak still happened, and then I got rid of the ones that didn't have parameters in it. I just had the one with the string in it, and that still reproduced the memory leak. In fact, it reproduced it faster. And my guess here is that there's some non-zero amount of time spent in rule construction, and when most of them or all of them have parameters in them, then it leaks faster. To like assert that, I switched to just a rule that didn't have any parameters, and there was no leak. This caused the leak to just go away. So I knew that it was related parameters, and basically had this structure here, and then just simplified the code to this here. What's going on in here? Oh, what's up, outdated version? Haven't seen you in a while. I found a memory leak at work today in a library that's used in Flask called werkzeug, and kind of explaining how I narrowed down my reproduction of the memory leak to just this small little file. And we're gonna try and fix this memory leak today, or die trying. No, I don't know if I'll be able to fix it, but I'll at least give it a good try. But yeah, so that's how I narrowed it down to just this. This is enough to trigger the memory leak. And in fact, just a single call to this is enough to show the memory leak. But and since you missed it, I'll run it again, and you can see the memory shooting up. So you can see like 1.5% memory, and then 2.5% memory, and this resonant set size is increasing rapidly. But yeah, and this memory leak doesn't happen in an older version of werkzeug. Particularly the 14.x or o.14.x release doesn't have it. Oh, they're gonna go 1.0 type. But yeah, the biggest change between 14 and 15 is this routing rule compilation change. Would work. PR 1281. I can just manually click on the PRs. 1281. And what happened in this PR, I've taken a look at it already. What happened in this PR is they switched from compiling or like building URLs at runtime to building functions that can construct URLs or something of the sort, using this builder compiler, which basically manually builds a code object at runtime. And it's pretty complicated. Huh. I mean, I know it's causing the bugs, so I feel like I might have considered the complexity a negative in like improving the performance, like improve the performance, but at what cost? Anyway, we'll look into fast URL quote. Fast URL quote. Oops, no, I don't want to bookmark you. Fast URL quote. Oh, I don't know why this is faster, but anyway. But yeah, I narrowed down the bug to like be inside of this code building object. So I'm gonna have to figure out how to code build, which is going to be fun. Or maybe I'll switch it into an eval template or an exec template. I don't know. We'll see. As it is, it's kind of hard to maintain, and it might be made easier by switching it to not do code building, but we'll see. Yeah, so I found this, and then I basically, this text is not super important. I explained like why we're using this and why memory is leaking ridiculously, and why it's not actually broken, although it could be if we weren't clever. I disassembled the two functions that get built, and when I initially looked at this, I wish you the best of luck. Hold my beer, we're going in. While disassembling these functions, I noticed one weird thing, which is this load const here. Usually load const is used to load objects that are stored on the code object itself, and usually it's used to load constants. And what I noticed here is it's not loading a constant, it's loading a method that has been attached to the code object. And at this point I was suspicious of this this load const here, but I did end up finding later that this is the probable cause. Because I compared a code object of the ones that didn't have these strings, and it did not have this this load const bit here. But anyway, that's present in both of these. And there's another load const that's present here as well, even, which I'm sure is also leaked, but we'll hopefully get to that eventually. This one might not actually be enough to cause a reference cycle. This one definitely caused a reference cycle. So from there, I adjusted my script to try and demonstrate which objects are being leaked. And so I took my infinite loop and turned it into a bound loop, which was only 10,000 things. Hey, what's up, Just Dan's 2011? Thank you for the follow. Every follow counts. So I reduced this to 10,000, which was still enough to show like a giant spike of memory, but it wasn't infinite, so that it didn't ruin my computer. Not ruin my computer, but actually be able to debug this. Running out of memory is actually not super fatal. Like, everything grinds to a halt, and then either the operating system kills it, or it just like restarts. I don't know. Then after creating these objects, I ran the garbage collector a bunch of times just to make sure that there weren't any objects that were being kept around. Then I introspected the garbage collector using the GC module. This is only available in CPython, so when I write my test that might or might not use the garbage collector, I'll need to like guard it against other implementations. You just download more memory. Yeah, if only. Yeah, let me sudo download more memory in production. I guess technically, like, you can kind of download more memory if you're like using AWS. You just throw money at bigger instance sizes and hope that's good enough. But this is causing like alerts in prod, and like can't do that. Yeah, so then I built a counter that, the goal of this counter was just count how many, or like which types of objects were still in the resident objects, which is what this function gives us. And then I wanted to see like what are the top 15. My guess here was that by limiting to the top 15, I could hopefully find 10,000 objects of something that are still hanging around. And sure enough, when I did that, I found that there are these 4 things here, and there's probably more in here. Like, there's probably 40,000 of these dictionaries that are related to these, and maybe some of these lists and functions. Well, definitely the functions, but I think 20,000 of the functions are related to this. But I don't know. I didn't bother like fishing that out and formulating that. Also, these methods, we know these are related to these Unicode converter objects, because we saw these methods up here. But anyway, this right here definitely showed me that at least these 4 types were being leaked, and that there's definitely a bug on our hands. Then the types after that aren't super interesting. I suspect actually all of these types are inflated due to the leak, because when I bumped this, I bumped this number. I didn't show this in the issue, but when I bumped this number to like 1 million, this ordering still occurred. Like, it was still dict list function tuple method set partial Unicode converter map rule, and then pennies after that. I, after 2 weeks, received my work laptop today and figured out a problem left on a cliffhanger yesterday, so it's been a good day. Nice! Wait, why did it take you 2 weeks to receive your work laptop? That seems like way too long. How is that not a day one thing? But yeah, figuring out those cliffhanger problems are always like, oh, those, I live for those. Like, some days, some days I'm really bad about cliffhanger problems, or like, it's like 4:15, and I usually leave at like 4:20 to catch my train, and sometimes I'll be working on a problem that's like right before my train, and if it's a really interesting problem, I'll just like take the next train and continue working on it, which is not super healthy for a work-life balance, but I actually think it's more sane than the opposite, because if I would have just gone home, I would start working at home instead, and I think that's way worse. But also, like, sometimes there's problems where I'll just stay up until like 2 in the morning working on them, because I think the problems are interesting. It doesn't happen too often, and most of those are usually with open source, and like, at least it's my code at that point. They did a big goof, yeah, you're telling me. I don't... Let's see, have I ever had... No, I don't think I've ever had a job where they didn't give me my laptop on day one. Even my, like, internship at giant enterprise tech company, like, they were like, yeah, welcome to Infor, here's your Windows laptop. Welcome to Enterprise. And yeah, like even day one there. Pretty unusual that it took you 2 weeks to get your laptop. Pretty unfortunate. Yelps was definitely day one. Lyft's was day one. I had actually... Lyft, they had given me permission to stuff before I started, so I actually made my first contribution to Lyft the day before my start date, which is pretty cool. And of course the issue is simple, but whatever. Yeah, I mean, sometimes the best issues are the simple ones. I've definitely spent way more time than I care to admit solving simple issues. Sometimes it's been like week-long problem, and eventually track it down to like a typo or something silly. So the next thing that I did after showing which objects were leaking was to try and generate some type of object graph to show like what references were keeping things alive. And so then I built a graph using this function, which is a little bit complicated. I'll kind of explain how it works. What's up, Ryan Roberts Cubs lover? We're learning Python. Well, that sounds great. I'm going into a bit of advanced concepts today, so maybe you'll notice something, but I do try and explain everything as I'm going along as well, so maybe you'll pick something up. Today I realized that for image manipulation you need to push a save file to a file in Python. In sandboxes. Yeah, I guess that makes sense. Yeah. But anyway, so the next thing that I was trying to do is to figure out which objects were keeping things alive on the heap. And the garbage collector gives us some methods for figuring that out using this get referrers function. And this tells you like which objects refer to other objects. And let me tell you, as I was writing this script, I must have typoed the word refer like 50 times because the HTTP header is a typo. It only has one R, and even Google knows what's up. But I've probably typed this word a million times, and I'm like very used to typing this version of refer, but Python at least spells it right. And I made the like pretty dumb mistake of naming my variable the correct spelling. I mean, maybe it's a dumb mistake, maybe it's the right thing to do, but I just like stuck with this and kept typoing it, and like punished myself for being correct. But I built this script. Let's see, let me check chat for a second. I'm in the first level of CS at my university. My next class is Design 2 and Mathematical Foundation in Computing. Interesting. I really didn't like my math CS courses, although they were probably the most like different than what I would have learned on my own. I don't think I ever would have like tried to do logic theory or any of the like
NP completeness stuff, that sort of thing. So they were definitely useful, but it was just like, ugh, math.
I remember the last one I took. We walked into the class, and the professor was like, "Welcome to EECS, whatever it was. I think it was 371, 373. I don't know. Oh no, 377. I don't know. It was a 7 class. Those are the math classes. But anyway, the professor starts lecturing, and he's like, "Welcome to the class. I am not a CS professor. I'm a math professor. So this is gonna be a math class." And then everyone groaned. And it was like, well, this is what we've signed up for, I guess. But I don't know. I did learn like a bunch in that, and I think it was pretty useful. Probably one of the things that I could have gotten it outside of school, but would never have really done it on my own. Thanks, HDP. Yeah, pretty much. And Layman is a streamer. Thanks for stopping by. Definitely check out his channel. Streams on Wednesdays, if I remember right, at 6 Pacific, 9 Eastern, if I remember correctly. Works on Python and Django and that sort of stuff. His stream's usually pretty educational. Classes, that's the concept I don't really understand. We touched it, but I haven't really done it that much. Anyone here taking data structures? I hear that's a true weed out course. No, the data structures course at Michigan was kind of the first actual computer science course, whereas like Engine 1 or Engine 100 was basically just like copy paste code and get things to work, and data structures was probably the first where you were like introduced to vectors and arrays and maps and all that other stuff and like how they kind of work. I'm nervous if I'll fail college if I major in CS. CS isn't that hard. You'll do fine. Let's see, reading. Oh, Effective C++. Yeah, I definitely remember that book. That was oof. That was a good book. Yes, I did go to Michigan. Copy and paste code sounds like the only CS class you need. I mean, realistically, I wish I would have had a course that was like, learn how to use Stack Overflow and Google to find your answer, because that probably would have been way more useful than a lot of the other stuff that we learned. But anyway, so I built this program to graph the objects that were being referenced, and it kind of has 2 parts. The first thing that I did was find all of the IDs of objects that existed. This was so I could filter out any of the garbage that got generated as like this function itself returns a list, and I didn't care about that list in my output because it's not related to the memory leak. Then I grabbed one of the map objects out of the currently referenced objects using this. This was just so I could find some part of the object graph to traverse from. And then I call my recursive graphs function. And it takes a couple parameters. The first is the object, the other is that set of IDs, so I can know when to filter. I also create a scene set so that I know to stop when I reach cycle points, so I'm not just like recursing forever. I set a limit so that it doesn't recurse for forever, and this indent string I use to print output. Then I loop over all of the objects that are referred to by this object, so like the things that are inbound to my object. Then I filter out anything that's a result of the script itself. So for those, it's actually it's trying to filter out this reference right here, because this is a hard reference from the function frame to the object that I'm looking at. And so I filter out things that are of type frame and have a global double under name called main. This is the easiest way that I found to just filter that out. So eliminate ourself, and then eliminate objects that were only present after due to this function right here. Then I also short circuit on stuff that we've already seen. And then after that, it's basically just like print out the object and then recurse with the limit decreased and the indent increased.
Lots and lots of chat. Let's see. My design 2 class and data structure is C++. Yeah, C++ is one of those languages where it's gotten a lot better, but it's also like pretty hardcore to get started with. Then again, like Michigan, their CS program was basically entirely C++. How to Google your error message 101.
Yeah, I could teach that course. Maybe I should make a YouTube video that's like, here's some tips about Google searching. Like it took me the longest time to realize that if you put stuff in quotes, it'll give you like exact matches. So like this only matches things that are the words exact plus match. And then things like site, github.com are useful to like limit to a specific domain. And then you can use like in URL to filter for stuff inside the URL. So let's say like if I want to filter to just this one down here, I can use RTFD. So these are the exact matches of the word exact match on site GitHub. But anyway, stuff like this was super useful to get better at searching. And then you can also do stuff like plus, which requires that a word gets oh, maybe plus doesn't work anymore. Does minus still work? Yeah. So minus is to keep something out of the result. Maybe it's just double quotes now? Yeah, okay. So there used to be a thing called plus, which would require that this word existed, but now it's apparently just double quotes around it. But anyway, Google searching 101, I guess. What's up, Ryan Roberts, Cubs lover? Thank you for the follow. Every follow counts. There's so many gen eds done as a freshman. Oh, so interestingly, I actually started in biochemistry, so almost all of my first 2 years just satisfied all of my general education requirements for CS. I got lucky there. Where are you going to school, Ryan Roberts? Oh, we're not done here, I guess. Yeah, so I ran this script and found the object graph. And so it basically started at a dictionary. And whenever you see this pattern like dictionary and then object, classes in Python, the way they're implemented is each class has a dictionary, which is all of its members. If we look at like class C pass, so we make just a blank class and give it some values. Foo equals bar, O equals high. This instance actually has a dictionary attached to it. So when you see this pattern of like dictionary and then class, the class or the instance of the class references this dictionary, and then the dictionary is how these members are implemented. And so that's what this pattern is here, where we have like a Unicode converter instance which has its instance attributes. But the kind of chain of references here goes from this Unicode converter to this toURL method, which is the thing that actually is partial above, but we'll see that in a second, which references this tuple. The tuple is just like the things that are oh wait, I don't remember where the tuple comes from. Oh, the tuple. This tuple is part of the code object. The code object doesn't actually get shown in this traversal, which I think is really weird, and it might be because it participates differently in the garbage collection. At least that's my hypothesis. I don't actually know that. That's just my guess. But this tuple is actually the locals argument of the code object, which we'll show later, but I happen to know that this ordering is where that comes from. We see that twice because there are two function objects in the rule object. But then we also see that this Unicode converter is referred to by, and honestly, this could have been the entire trace, and I would have known where the bug was just from that. But it turns out there's two additional cycles, and usually the Python garbage collector is smart enough to collect cycles, but because a function object got involved here, it wasn't able to do that. Or at least that's my guess. I'm not like 100% sure. I'm not a super expert on this. That's just the guess that I came up with, and we'll verify that hypothesis later. But breaking this cycle actually fixes the garbage collection as well. But this is the more important one. Actually, I don't know if that's true. I think I broke this cycle in Unicode Converter itself, and that caused it to collect, but shrugs. But anyway, this one's not super interesting. This is just like the members of rule and map refer to each other, and so you get this this cycle of a list that contains a rule, and that rule has a dictionary, and this dictionary refers to this, and blah blah blah. I also found that here's how I can break one of the cycles. So part of the cycle was this converter, which is what this Unicode converter is. It refers directly to this map, and by making it not refer to the map, but just refer to a string inside of it, that broke the cycle, and that caused it to not leak anymore. But then I switched to, or I'm switching now to trying to investigate this load const, because I think that's the actual problem. But that's that. Let's see. UIC, pretty close to Michigan. Oh, Illinois. I had a bunch of friends who went to Illinois. It's a good school. A lot of good CS students come out of there. So you're up for a good education. Sucks because UIC is a med school. I see. You have to take a science lab class. I mean, science was required at Michigan as well. I just happened to like overtake it on accident because I was doing a different major. Yeah, I don't get those people who do projects an hour before it's due. Like, that is stressful. I usually start projects when they're assigned and get it over with. Yeah, I mean, there's like two schools of thought for almost all work. One of them is like get it done right when you can, and then the other one is the severe procrastination. And I totally get the procrastinators because I did it for some of my projects, and you get the adrenaline flowing, and it feels like you just have all this power, and sometimes like working under pressure gets it done faster. I don't know. It's sometimes better, like sometimes in like an elevated state of mind. I don't know, but I totally get it. But I was definitely one of those like started as soon as I got it kind of people. One coding nightmare in my first CS class. I spent 7 hours the day a project was assigned and was wondering what the numbers meant. Next day in class, I asked the professor, and I realized he forgot to put an ID. Lost 7 hours of my life. Rip. That's unfortunate. I thought the numbers were right angles, and my professor was saying this isn't rocket science. Trying to rebound after high school, graduated with a 2.6. I was a party animal and never did homework and stuff. So far in college, I have a 3.0. As long as no unlucky event happens. I mean, yeah, I think you'll eventually learn that your grade point only matters to get to the next level, and then after that, it's pretty useless. I don't even think I put my high school on my current resume, like high school or grade point average, even though it was a big part of who I was in high school. And I think I don't even list my grade point in college, even though my grade point was really good, and my college was good. But like, after a while, it's more about like what experience you have and like what places you work at. You don't need a master's for CS. Yeah, you definitely don't. I don't have one. I think of it like Top Gun for projects. Maverick seemed like the type to do a project last minute. Iceman seemed like the start the project early type. I'm definitely more of an Iceman. Nice. I can't open this bottle of mustard. Well, I can't help you with that, man. That'd be pretty amazing if I could just like reach through the screen and like open your mustard for you, but no can do. Anyway, so now I'm gonna start looking at this code and try and figure out where these load constants come from. Actually, let's write like a quick test for this first. Just so I have something to iterate on quickly to see whether this is actually happening. So the easiest thing that I can do is just construct 100 of these and then use the garbage collector to look at whether we get map objects out. Oh, I got rid of my import. Map rule. Count equals sum1 for gc dot get objects map or rule. I don't think it actually matters. So we should expect. Oh, I need to do the garbage collection first too. Yeah. So this is kind of the basics here, like build a bunch of objects, run the garbage collector to make sure that they get collected. We run it multiple times so that cyclic objects get collected, because implementation detail, but CPython will only collect cyclic objects after several rounds of GC. And then at the end, validate that we have none left. We should be able to run this test now. And it should fail. Oh, that's not what I wanted. We're in the whole test suite again. Dang it. PyTest t.py. Get objects. Solid typo. Yeah, so we see now that all 100 of these objects are still alive, and so now we'll try and work through fixing those. Let's see. Is data structures like the true weed out course? It depends on what school. Like, for Michigan, it was actually not data structures. It was 281, which was, I think, intermediate algorithms or something like that. That was the, like, you knew you were gonna do it or you weren't. That was also, like, I think the hardest course required for the minor. Like, you would take. The core required courses were either 100 or 183 to get intro, then it was 280, 281 to do data structures, and then algorithms. And then you needed a bunch of associated courses to get the minor. But those were all elective, like CS electives, so you could pick whatever you wanted. And then you needed a bunch of those to get the major. What did I take? I took web databases as well as databases, although web databases was not really about databases. It was mostly about, like, here's web development from 3 years ago, because it was already outdated when I took the course. Like, the course was in PHP, and I think at that point, like, PHP was definitely not something that you should start new projects with. Databases was a good course, although we used Oracle DB, which terrible database engine. Like, I mean, it works really well, it's super performant, but it has, like, no features. The REPL didn't even have tab completion or, like, read lines, so you'd literally have to copy and paste the previous line you typed. You couldn't press up, which is super frustrating. And, like, we built a bunch of hacks using RL wrap, which is a tool for wrapping something that doesn't support readline with a readline pseudo thing. That kind of worked, but oh man, that was real frustrating. Also, it doesn't have, like, auto-incrementing primary keys, which is a pretty basic function that you would expect out of a relational store, but didn't have that. I don't know, I could grumble about Oracle for quite a long time. Also, we had to, like, we couldn't download our own version of Oracle DB because it was something that was paid for by the university, so if you wanted to run your own copy, you were just, like, shit out of luck. And I had done a bunch with MySQL, and so moving from MySQL to Oracle felt like a huge step down. But anyway, that was that course. What else did I take? I took operating systems, which I really liked. I really liked operating systems. There was a lot of, like, low-level stuff dealing with computers. What else did I take? Oh, I took 381, which is advanced algorithms, although it really ended up being, like, a deep dive into everything that's new in C++ and building the STL from the ground up and, like, understanding that stuff really well. That course was great. It was really hard, but it was a really good course. Surely I did more than that, but I can't remember. I took programming courses in high school, but wasn't sure if I wanted to do it. Oh, well, at least you had programming courses in high school. The most advanced computers course at my high school was Introduction to Microsoft Works. So not Microsoft Office, but Microsoft Works, which is like the shitty knockoff one that like our school district couldn't afford to get actual Microsoft Office. So whew, that was a mess. I spent most of the class. Well, actually, I tried to test out, and this is bullshit. I like passed the test out quiz, but they invalidated everyone's test results because apparently there was bolded periods on the correct answers for the entire test. But like no one picked up on it, so I don't know why they invalidated the test and didn't just like retest us. I was pretty salty about that. But I spent the whole class playing Minesweeper, so I think it was a really great use of my time. The PHP is the definition of web scale. Yeah, that web scale sauce. I mean, HHVM is actually pretty fast. So if you understand one language, do you basically understand other languages? To some extent. I think once you get good fundamentals in a good language, like if you get fundamentals in C++, that'll apply to most similar language types. Now there's kind of two approaches to programming from what I've seen, or like several different approaches. Like you have your object-oriented languages, things like Java, C#, etc. You have your functional languages, which are things like Lisp and things that I don't know anything about because I've never really worked in a functional language. Then you have like multi-paradigm languages, which is like Python, Ruby, etc., where you have like you can do object-oriented stuff if you want to, or you can do functional programming if you want to, or you can do imperative programming with functions and stuff. But you can kind of choose your own adventure. But for the most part, like you learn C++, you'll be able to do Python pretty well. You'll be able to adjust to Ruby or JavaScript or whatever you really want to work with, or whatever you're needed to work with, and that it translates pretty well. Did you do Linux kernel stuff in your OS class or an educational kernel like Notch OS? So we didn't implement a full kernel, but we did build some kernel modules. Like we built our own file system driver, and we built our own memory management thing. Although the way it worked was kind of hidden away from us, which I was really sad about because that was the part that I thought was really interesting. But they basically handed us like this shared object file that did all of the like super low level stuff, and then we're like, implement these interfaces that kind of look like what the processor would do. It was I don't know, it was good though. Like it was pretty close to what you would have actually needed to implement. However, they just like changed the names of the functions so we didn't have to write assembly to make syscalls, which we could have done. Like could have just like exposed some inline ASM to do syscalls, but I don't know, it was pretty good. We built our own like semaphore implementations based on the syscall primitives that we were handed, and we built our own threading library and like a thread scheduler and that sort of thing, which was pretty cool. I still have the code somewhere, but it's some of it's really awful. Also, some of it, the last bunch of projects were group projects, and my group of friends would always want to drink while programming, and so we would start drinking, and then they would decrease in productivity, and I would like kind of stay the same until I got drunk enough, and then I would just stop working. And so a lot of our code is just like my friends writing like bullshit comments or bullshit variable names, and then like some of the code makes sense, but like none of it makes sense when we sober up. But I don't know, it was pretty good. I remember we only lost style points once from this like practice, and that was in our networked file system. We had a global lock that we called the badass lock, and apparently our professor was not amused with that naming scheme. But I don't know, I thought the badass lock was actually a pretty good name, despite what was told. Let's see. When you have to take 14 free credits just so CS matches the other fields of engineering credit hours. Yeah, I guess that...
Oh, can I link you? Yeah, you can put links in chat. I don't limit links at all because I find, at least with programming, like we have to share links all the time, and so it hasn't been abused yet. So don't abuse it yet. Let's see. Let's look at what your Bachelor of Science is and say 48 credits in non-engineering, total 128 hours. So my total was 120 hours. I had to do 40 CS credits. That looks like what this is here, mostly. This is actually a pretty good balance. We also had the required math. Free electives. That's actually not that many credits to look around. I took way more free credits than that. Then again, I also graduated with like 180 credits because I started my major late. Non-engineering general ed requirements. So yeah, we had to take an English course. Depending on whether it was our... Let me make the text size bigger now that I think about it. Depending on whether I took the engineering or non-engineering CS, I had different requirements. The engineering CS was way easier at Michigan, or like it had way less requirements. You had to take technical writing, and that was your English course, and so like we wouldn't have to do either of these. It would have just been like one of these, and it was just technical writing for engineering majors. Exploring world cultures, creative arts. So I had to take a creative arts course. Oh wait, no, I didn't. Is that the one that I got away with not doing? I think that was the one I got away with not doing. Understanding the past. I mean, this makes sense. Like, take some breadth. This was not required for the engineering one, although I took the non-engineering course schedule, so get more breadth. I think you might not appreciate it now, but when you're searching for jobs after school, you'll definitely appreciate this like breadth of knowledge. They actually did a study at Michigan that showed that the non-engineering CS non-engineering CS students were like 40% or like 30 or 40% more likely to get a job, or like get a job faster. I don't remember what it was, but it was some like absurdly large statistic that the rounded out education actually proved to be much more useful than not. And this calculus requirement is pretty standard. Although, did Michigan require Calc 3? I think so. Although I took more Calc than I needed to. I originally thought I was going to do a minor in math, and so I was like 4 credits away from that. But I took like, it was called Applied Honors, but it was really just like small class-sized normal calculus with a little bit more practical application. But I took Applied Honors Calc 2, 3, 4. I took differential equations. I took one other course, I think. I don't know, but I really like the math courses. But I realized that math is like, you kind of have 2 choices with math. It's either like get that as a major and then do something else, or go into academia, and I didn't really want to go into academia, so I said no to that. This seems pretty standard, although this is a lot more courses. I guess you guys only had like 3 credit courses. Oh, this one's 4 credits. Huh. So ours like gave us a lot more freedom here. I guess I can just open it up. So UMich, LSNA, CS requirements. Computer science major. Let's see. So 27 upper level credits. You have to take these 4 courses. Okay, so 203 was discrete math, 280 was intro to data structures, this is Calc 1, and this is Calc 2. So that was the prerequisite to declare. This is algorithms. This was computer architecture, which I really liked this course. This was like another low-level systems, like write an assembly language, write an assembler, that sort of thing. This was the math course. Computer... was it? I don't remember what it was called, but this is the one that I didn't like, which was the math professor. And then statistics. This has changed a lot. Oh no, this is just, you can choose from any of these courses. I see. I took this one. which I should have tested out of, but they wouldn't let me test out, despite taking the AP course that like definitely taught me way more than this class did. So I just like fucked around the whole time. Capstone course. This is new. This was not a thing before. Oh wait, no, it was major design experience course. Yeah, I definitely took one of these. I took mobile application development, which is basically like the teacher was a guy who had failed a bunch of startups, and he didn't really know much about mobile applications, but knew a lot about like selling a product. And so most of the course was like in class. We talked about like current events, and we did presentations on our stuff, and like learned about how to speak in a technical level, and like how to build a pitch deck and all that other stuff, and, like how to look for VC funding, that sort of stuff. We also there were a couple of courses where like outside speakers would come in and we would talk to them, and I don't know how we convinced this lady to come in, but she was a technology patent troll lawyer. So like the current event at the time was the like Samsung was getting sued by Apple for pinch to zoom, or it was rounded corners, or one of those. And this patent troll lawyer comes in, and we all prepared for this because we knew she was coming in. So like all of us like spent weeks like coming up with these super hard questions for her. And oh, this poor lady, she was almost crying by the end because we had some really brutal questions. But that was a fun day. That teacher was really funny too. He had like a series of catchphrases that we would try and sneak into all of our presentations. And one of them was, oh well, in 5 years, such and such is gonna happen, and 5 years after that, this is gonna happen. And so like, we would try and sneak 5 years into whatever we talked about. But anyway, enough about that. And then upper level CS technical electives, 16 credits of those. So these were like operating systems, databases, that sort of thing. Honors. Oh fuck, I could have gotten honors. Graduated with 3-2. Okay, I did that. 4 prereq courses. Took those, yeah. 3-4. I could have gotten LSA honors. Senior thesis. Never mind. I was not gonna do that. Oh wait, senior thesis course. No, I took that. Write a thesis. Did not do that. Oral presentation. We did do that. Damn, I could have had honors. Oh well, didn't do that. There's also the like the LSA requirements, which everyone has to do. Well, they changed the website. I don't know how it works, but anyway, there's like a bunch of like, you need to take this much science, this much social studies, this much English, etc., etc., etc. Oh boy, I'll have to scroll back now. Let's see. So you have a little bit more requirements in like core classes. We had a lot more freedom here. Technical electives, yeah. So these are the courses that you can kind of choose from. These sound pretty cool. I wish I would have taken this course at Michigan, because I feel like I've never had to struggle through a web database, but I've had to write like, or I've done tasks where knowledge of compilers and parsers and design would have helped me a lot, and I've actually written my own parser and quote-unquote compiler, and they're pretty garbage, and I wish I would have been able to do that better. Did you do partial differential equations? Yes, I did. The partial differential equations was lumped into our diffEq class when we also did linear algebra. So that was all one course, and so we basically like sped through all that stuff. And I remember the professor being like, "Okay, I know this course is called differential equations, and it's not going to sound like we have enough time to cover all 3 of these topics, and we don't have enough time to cover all these 3 topics. But that's what's on the syllabus for the course, and I don't have any choice. That's what the department told me I have to teach." And so we basically like crammed all that into one semester. And it was pretty crazy time. I heard linear algebra is easy. It's rows times columns. I mean, that's a little bit oversimplification. I mean, I think it's definitely very mechanical. You're definitely like applying the same strategies over and over, but I wouldn't go as far to say it's easy. Then again, like most like science libraries in Python nowadays are really just like differential equations and linear algebra solvers, which you know, take with it as you will. Let's see. Like, what concepts would you say to understand in CS? Building blocks, functions, ifs, whiles, etc. Don't really understand classes. You'll need to understand classes. That's kind of important. To get out of your CS degree, it kind of depends. Like, I think one of the things that's really important is to understand like basic like gut feel about how to approach some algorithms, like know speed and stuff, like what data structures work in what ways, that sort of thing. But I think the biggest thing you can get out of school is to meet a lot of people that are going to be working with you, or like are going to be working on related fields with you for the rest of forever, and network as much as you can. Because it's really like it's pretty important to have people that you can talk to about this stuff. And if you don't have any people that can do that, then a lot more rough. She was basically crying by the end, continues laughing. Yeah. I mean, it was mission accomplished, right? My econ teacher always talked about drugs. LeBron James. Interesting. And other things that I'm just not going to say on stream, because this eventually goes up on YouTube, and I'm not monetized, but I also don't want my videos taken down. Let's see. Heard compilers are suicidal. Yeah, that course was really hard at Michigan, which is also why I wanted to take it, because I thought, like, I'm good enough to do this. Only slightly a narcissist. It's also exceptionally warm in San Mateo today, which is where I live. It got up to 90 Fahrenheit, which is like, I don't know, 28 Celsius-ish. But it was like high of 60, like high of 17. Just yesterday, and so like, where did this weather come from? So I'm like sweating and really hot. So if you notice that, that's why. Can someone explain how math relates to CS in any way? So it depends on your field. My field, I've literally used math once. And I can show you the one thing that I use math for. This is it's supposed to be an image carousel, so there's supposed to be like images in here, but I didn't finish the images part for this little demo. But this like slider thing, make it bigger so you guys can see it. This like gradual slowdown thing, I used some calculus to do that. And also these like left and right bumpers. I use some calculus to do like the curve of how it slowed down and how it eventually stops. That's literally the only time I've ever used math, or like complicated math in computing. But like depending on your field, like if you're doing data science, you'll do a bunch of like statistics for that. If you're like writing video games and stuff, you'll deal with like ray tracing and plotting and collision detection, like projections and all that sort of stuff. I guess I did do projections when I did Advent of Code, which is a cool product, or not product. Let's see, log in GitHub. So like Advent of Code is like a bunch of like puzzles that show up in January or show up in December, and so I guess I did use some math for one of the puzzles where I did this one. No. Day 23? Yeah, this one. So this was three-dimensional octahedrons, and I had to project them into 2D space, and then project the 2D space things into 1D space, and then do collision detection that way. So I did some math there, I guess. But I've never like professionally done math except for this thing, which I built this for one of my first internships. Ended up getting used as a navigation gateway for a bunch of different applications and stuff.
But most of CS I find is, or most of programming is like adding and subtracting 1 or dividing by 2. Like that's the most complicated math that I tend to do. Let's see. You use math regularly if you do game programming. I mentioned that. Good, got that. But it's limited to trigonometry. Yeah, I guess I didn't mention the trigonometry aspect. You have to do that as well. I hope to either be a game dev or a software person. So I don't want to discourage you from game development, but I actually tend to think that's the hardest and least rewarding part of software development, or like field of software development, unless you're like working on your own schedule. But even that's like nerve-wracking, whatever. Mostly because like the hours are really long, it's incredibly competitive, and you get paid less than other equivalent things. But it can be fun. Like making games is, I enjoy making games, but I don't make it my career. Like it's a hobby of mine, and not really something that I can make money out of. Let's see. Hey, always like tuning in and stream. Yeah, thanks for tuning in, Goomback. How's your Tuesday going? I don't want to be a web dev though. Well, there's a lot of like web development is kind of a broad thing. What is this? I didn't mean to bookmark that. I mean, web development can encompass a lot of different tech. Like you could be an engineer that works on servers that like builds APIs for stuff, and that would be considered web development, even if you're not building websites. I don't know. I wouldn't count out web dev because that's a huge part of the industry. Like I technically would maybe refer to myself as a web developer, even though I work on like developer tooling and infrastructure for Lyft, which is kind of a website, even though most of it is APIs that like mobile phone apps deal with. But the web development part of that is still relevant. A lot of software is done via web now. It doesn't have to be boring. Yeah, I mean that's certainly true. Like APIs are web development. It doesn't have to be websites. Now I can, like if you change what you're saying to more like I don't want to be a CSS JavaScript developer. I don't want to work on front end. Totally get that. I did that for years, and like while I enjoy it, I would rather work on stuff that's not that. What does a compiler? I assume you're asking what does a compiler do, or like why would I want to know a compiler? So a compiler on the tin takes source code and turns it into some other representation. The most common one that you'll probably deal with is like GCC or Clang that takes C or C++ code or other related code and turns it into object files or LLVM and like stitches that together into an executable. But a compiler can take many other forms. One that I worked on, which is not like a great example of a compiler, but it's this one's called Yelp Cheetah, which is a fork of a templating language called Cheetah. And what the compiler portions of this would do is parse some syntax that, I guess I can show an example of what the syntax looks like. Oh, that's not it. This one. So like a template. So it would take syntax that looks like this, which looks very much like Python, and at the end of the day, it gets compiled down to Python. Thank you, Salvan, for following. Every follow counts. And so like the compiler portion would take these like pound directives and these $sign placeholders and compile that into Python, which would then run using Python to generate template output. And so like in this case, like these are just plain Python imports. This is a with block, which allows you to put code before and after whatever the contents are. Like this would get injected into whatever this layout.html thing does, which I happen to know it like let's see, view source anthonysatilli.com. So the HTML block happens to do like this tag, and oh, there's two end HTML tags. Great. Well, found a bug. Let's go fix that. How did I screw that up? let's see, lib layout and HTML. Sure enough, there's 2 HTML tags there. Move, duplicate, and HTML tag. So yeah, even I do some web development, although I haven't actually updated this website since 2012, so. I did rewrite the backend recently because I switched. It used to be PHP, and I wanted to stop paying GoDaddy like $100 a year to host a static website, so I moved it to Python. But anyway, this is like a different language that gets compiled into Python. I can kind of show what the Python looks like too. There we go. How does the makefile work? Because I'm just gonna make and find out. Some stuff. A lot of stuff. Right, so what was one of those examples? Base.py? Index.py? Yeah, so this is what the compiled Python looks like from, let's see, index.temple. So like these imports get hoisted to here. This import always happens for the base class that gets set up here. There's some like special directives that make things show up as for introspection purposes. There's some like boilerplate at the beginning of each method that gets compiled. So this gets compiled into a respond method. And this is basically the code that's from here. So you can see like this with statement ends up as being this with statement here. This writes this white space that happens to exist here. It doesn't really do anything, and there's ways to remove it, but it's not important, so it ends up there anyway. Then this layout head function gets called, and if it returns a value, so functions in this templating language can return values or they can write. If it returns a value, it will get written out here. But then most of it's just like stick HTML in, call functions, etc. And this is all entirely generated from the Yelp Cheetah compiler. So that's how that works. But anyway, that's the only compiler that I've like written from. I guess it's not true. It's the only like legitimate working compiler that I've written from the ground up. I wrote another like parser and thing, but I never finished it. But I wish I knew more about compilers, because the person who wrote the original compiler that I modified didn't. I mean, I don't want to say they didn't know what they were doing, but the code was just completely insane and really hard to trace and like really hard to do anything with. And so I always had this like this goal while I was working on Yelp Cheetah to rewrite it with an actual sane parser and compiler, but I never got to that. The joke was I was going to rename it to Tortoise and then re-release it as a fast templating language, because it is technically the fastest pure Python templating language that exists. I did some like crazy stuff to get benchmarking to be like really good. There's some like clever stuff that the compiler does to optimize variable lookups so that they don't go through the slow path of Python variable lookup. But that helped things get way faster. And this actually made Yelp.com, the template rendering portion, I managed to speed it up by like 60%, which translated to like 200 milliseconds on the business page, for instance. But anyway, it's deprecated at Yelp now, but whatever. I spent a bunch of time on it. I was pretty proud of that project. But anyway, that's what compilers are. This is an example of a compiler, but it's not really like on the tin what compilers are gonna be. Let's see, what tips would you give someone who struggles with logic? I really struggle with code. Syntax is not the problem, but the branching is. So I would suggest like practice a lot. I think that's really like the biggest thing for me, and like how I learned how to like kind of think in a program way. So it's really just like find projects, work on them from start to finish, talk with other people who work on code to like review your code and like get tips and tricks on like how to adjust logic and algorithms and stuff. But I don't know, I don't have any real concrete advice other than like try stuff. Dude, I got no idea what is going on with your screen. Well, I mean, looking at generated template output is probably not the best example of code, because this is not how a normal person would write code. In fact, like there's all sorts of like linting errors and stuff, and like weird code that's going on here, but it does work. In fact, I think if I run this, yeah, if I run this, it spits out the output of the web page. So it works. Yay. Drafting Interpreters is a really solid book for dealing with writing parsers and languages and stuff. Interesting. I'll have to check that out. Craftinginterpreters.com. Oh, that was weird. Gave like a not found before it rendered. Interesting. Oh, I can read it for free online. Perfect. I'll definitely check this out. Let me give myself a bookmark in the browser that I actually use. So I only use Chrome for streaming. Mostly so I can keep like other stuff open and keep logged into work stuff on Firefox. But anyway. I don't really know how to play with code or practice code. I think like the best way to play with code or practice code is either like get something that you want to automate and make it happen, like find a project for yourself and work through it. Or you can always go through like little exercise websites. So things like what is it called? bytecode, which is like a bunch of like interview-like questions where you can just like answer them, and it gives you answers there, and like you can some of them you can, I guess you can run them online. Pretty cool. But like, you know, there's like lots and lots of places where you can just kind of find yes, YouTube, I'm still listening to the background music. You can find like lots of little code challenges like this. Kind of weird to me that this, like, they should have named it like this. Why would they do this? Anyway, OCD. Oops, no, we don't want to do that. I instinctively typed Control S to save it. But anyway, yeah, like, elite code is one way to get a bunch of programming problems. Or you could do stuff like Advent of Code, which starts at, like, there's one for every year, and they start it really easy, and you can try them whenever you want. I did 2018 on stream in December and January, but like, you can start with the like very first question, and they're super easy, and you can find other people's solutions online, and so it's often good to like learn how other people approach problems. Then they get really hard by the end, so maybe not get all the way through, but I don't know. Finding puzzles to do is probably a nice way to do that. Is HackerRank ever good? I've never done HackerRank either. Hey, what's up, Peaky Dicers? Peaky Dicers was streaming on Saturday. I mostly just watched you eat food, though. What were you working on? Oh yeah, you were working on a Java app or something. I don't quite remember. But yeah, I mostly just watched you eat food. What do you work with nowadays? So most of the code that I write today is in Python. I work at Lyft, which I'm kind of isolated for most of the like interesting stuff at Lyft. So where Lyft is working with like consumer applications on phones or autonomous vehicles and that sort of stuff. I work mostly on developer tools. So I build like tools and infrastructure that make the development environments work. And I also work on tools that make it so developers can like notice problems with their code quicker than noticing errors in production. So things around like testing and linting and other stuff like that. Like some of the like my passion projects are, or my passion project is pre-commit, which is this like linter code formatter Git hooks framework, which I spend a lot of my free time working on. I also work on a bunch of other stuff related to pre-commit and linting and testing. Like I'm one of the maintainers of PyTest, so the Python testing framework. Spend a bunch of time on this. I'm not the main maintainer, but I'm up there. There's 400 contributors, and I'm like number 7 or 6 or something like that. 7, not bad. And honestly, I could put in a little bit more work and probably pass this guy. Benjamin P hasn't been working on it in a while either, so like I'm moving up. Although he's been spending a lot of time recently on this. But anyway, I work on PyTest. I work on Flake 8, which is a popular Python linter. I work on a bunch of my other project or like associated linters and code formatters for pre-commit. I also work on some like virtual environment testing related libraries. I don't know. That's like my open source stuff. I'm really happy when I get to use some of my open source software at work. But it makes developers happy too, because like before like 6 months ago, if you wanted to do linting at Lyft, you had to download this like 0.5 gigabyte Docker container and then run this like janky ass VirtualBox setup that would like eventually spin up, and then you could run linters and they would show you errors with your code, and then you would have to like iterate on that, and it was super slow and super annoying. But now that people have pre-commit, they can just run it directly on their laptop, and everything is great. And because it was such a pain to run linters locally, people would most often just like push their branches and like check it with Jenkins and call it good enough, and like their iteration cycle was often like many minutes when it could have been like instant feedback on stuff. So we're working on like empowering developers to notice problems as soon as possible, which I'm really excited about. Damn, you work at Lyft? That's sick. Yeah, I like working at Lyft. It's I really enjoy it. How long have you been in the field for? So my first software engineering job, well, my first like technical job, I was a QA developer in 2009, or QA intern in 2009, so 10 years ago. I switched to engineering a week into my internship because I automated my entire internship. Then I was an intern for a couple more years. Then I worked at Yelp for 5 years. I started as a front-end developer. Then I did full-stack development, and then I eventually moved into infrastructure and developer tooling, which is where I really found the stuff that I like working on. Then after Yelp, I went to Lyft, and I've been there for 1.5 years working on developer tooling and infrastructure. Really enjoy it, and really, I like the stuff that I work on, and I'm fortunate to get the time to work on tools and stuff that I really enjoy. How did you get to... Oh, let me look at this image first. Risky click, although it's a .edu, so it's probably fine. I'm assuming this is a professor. Stunning reaction. I didn't even see the clip. What's the clip? We'll look at the clip. Run them online? Like, solid facial expression for me. Great. How did I get to write quality code? Ooh, that's a good question. Because a lot of the code that I've written is garbage, and I will be the first to admit that. Oh, this doesn't have a website? Let me put that in. Precommit.com. Nice. So I think a lot of getting to writing so-called quality code is to practice a lot, and I think the places where I've improved the most about writing quality code is learning from other people in the industry through code review and such. Like during my first internship, I had very little code review. It was super enterprisey. I was not given much technical direction, so it was mostly just like write code and good luck, I guess. Thank you, Tig, for following. Every follow counts. So I wasn't given much like technical direction on the quality of my code there, and so like my only output or like outside input on my code quality at that point was static type checkers and linters. And so like I think it was JS Hint and JS Lint back in the day, because I had started as a JavaScript developer. But like most of that was just like static analysis tools telling me what was good and bad, and then like learning from that, I guess. But I think when I really started improving at code quality and like design and that sort of stuff was working in industry and working in an industry where, or working at a company where code review was a required portion of development cycle. So at Yelp, like in order to get a change out to production, you would work on your feature branch, push it up, run tests against it, and put it into code review. And you would have to get at least one sign off from someone else before you could push it. And often the sign off portion was a huge learning experience for me, but also for everyone else. Like you learn more, like the other person learns more about the code you're writing, and you learn more about their suggestions and like better ways to approach problems and stuff. And like I think that was probably the place where I improved the most, was like doing code review and that sort of thing. Am I headed to PyCon? Yes, I will be at PyCon this year. Which it's been a couple years since I've gone, mostly because I was like between jobs at one of them, and Yelp did this like super sketch ass thing where you had to like meet some like interview quota and then like give enough tech talks or some bullshit, otherwise they wouldn't sponsor you to go. And Yelp also went through like a really bad financial year where they were just like trying to cut corners on everything, and one of the corners they cut was external talks, and so did not get to go to PyCon that year. But I'm going this year. I basically, so Lyft gives us or gives engineers the opportunity to take one technical conference per year and have that completely comped, and so I'm doing PyCon for that. Thank you, NDR4581, for the follow. Every follow counts. But yeah, I'll be at PyCon. I'm hoping to meet up with a bunch of people that I've only talked to online and hopefully see some people in person. Are you going there? Hopefully, then I'll get to say hi in real life instead of just over Twitch chat. Can you fix my computer? No, I cannot. I can barely fix anything. I guess it's not true. I can build a computer. I can't really fix it. When things go wrong on my computer, I just build a new one. Wish me luck on my CS1 exam tomorrow. Well, good luck, my dude. I'm sure you'll do fine. It's gonna be a struggle. Oof. I don't know how my Twitch stream is gonna help you, but good luck. Do you have any advice for someone trying to find a software internship? Yeah, I do have advice. I think the biggest thing for software internships or like trying to get a job is, especially if you're like just entering the industry, is to work on personal projects. For like for a couple of reasons. Like one of the reasons is because it demonstrates passion for trying to build stuff. Like it shows that you're willing to like investigate on your own and like build your own software, but also because it gives you practical experience. Like if you're like setting out to build an application, like you have to learn a bunch of associated things on how to do that and how to make that happen. Oh, you're heading out, Ryan Roberts? Well, thanks for stopping by. It was good to see you. Good luck on your education. Hopefully I'll see you around. But yeah, I think like the biggest thing for finding internships for me was like I had some projects that I worked on that I could talk about and like demonstrate problems with them and like problem solving skills that I used to make those happen. I think that was probably like the biggest thing for me. Cool. Maybe I'll see you there. I'll be at the Doctor on Demand booth. I'll make sure to stop by then. What about my printer? I cannot fix your printer. There's absolutely no way I can fix a printer. I don't own a printer. I haven't owned a printer since 2008. I guess I owned one in college for my first year, but then it broke, and then I was like, I can just use the school prints. Like I basically had like 100 prints a semester, and I think I used like 5 of them, and it was only like when I had to turn in my English papers. But yeah, I don't know anything about a printer. I did try and configure printers on Linux once while I was at Yelp, and man, cupsd is some of the most like insane configuration ever, and I was not clever enough to figure it out. Fortunately, my good friend Chris knows way more about Linux and and configuring printers and mucking with cupd from like running OCF, where they run printers for Berkeley's computing facility. So they know way more about cupd than I did, so I just stole his config for using printers. But yeah, don't know anything about printers. Yeah. So anyway, that's a nice hour-and-a-half tangent. Let's see if I can actually make some headway on this this memory leak problem. What were we doing? We made this test file, yeah, and then we ran it. Yeah, okay, so memory leak, demonstrated memory leak, check. And the meat of the code that is involved in this memory leak is inside this routing.py file, which we don't really care about what it actually does. The important parts are this. Oh, my editor has. Maybe we'll use Vim for this, so you guys can think I'm less of a noob, even though I'm definitely using the arrow keys. So judge me hard and go for it. Build. Yeah. So most of the way this, so it's a code generation. So it builds these function objects that represent these path things, and this builder compiler thing takes in the parsed path and then creates a function object from it. And so we need to basically adjust how this builder compiler works so that it doesn't store non-constant variables into the constants field. And so I think it's const something. I thought I knew how to use Vim. Oh, I didn't need to escape the parenthesis? Okay, so it's not true regular expressions. But anyway, here's where the constants get added, it looks like. Oh, this is just where they get collected at the end. I don't know how this works, so what we're gonna do is we're gonna... Oh, I don't have... These are actual tabs. I'm gonna put a breakpoint in here and see how this executes. Oh. Breakpoint is only available in Python 3.7, but you can install it into earlier versions of Python by installing Future Breakpoint, which is a I don't want to say terrible, but kind of a cheeky hack that I wrote. But this makes it so that the breakpoint built-in works in older versions of Python. So now I have a debugger. I would normally use import pdb.setTrace, but I'm setTrace, but I'm trying to condition myself to use breakpoint more instead. Shift K. Oh, that was not what I wanted. That was not what I wanted. Oh, what have I done? Oh goodness, what have I done? Press enter or type command to continue. Okay, we're back. Nope, don't know what I'm doing. Don't know how to Vim. But anyway, I've been trying to condition myself to use breakpoint more because it's the new thing, and hopefully the old thing will go away eventually. Okay, so emit build. I don't know what's going on here. This is in the... Which function are we in? I guess we're in the compile function. Yes. So we should have OPL here. Okay, so these are the different components of the URL, it looks like. These variable names are a little bit sketch, but So the thing that we're compiling looks like /a/string b, which gets partitioned into this chunk here, which is just a static non-converted string, then a converter, which is a Unicode converter object, which writes into the variable b. And then, okay, so we build up all those operations, and then I assume at the end here, we build together a function object. Oh boy. Okay, so this emit build returns more code objects, which is what this RV is, I think. Ops. Yeah, ops is this byte string that is the code object, I think. Yes, it definitely is. Cool. So I'm starting to figure this out. And peak stack, I think this is this peak stack get used for. Oh, this is just the maximum stack size of the function object, maybe? So it knows how big of a frame to build up front? Yeah, I think so. Every time I try to practice Python, I have nothing to do with it. What do you suggest? My favorite like dummy project to build with any language is to build kind of a chatbot. So if you have like a Discord group where you send memes to your friends or whatever, or like however you communicate, like there's often good libraries for writing chatbots for that. Like I did one for my stream to learn async IO in Python. Doesn't have many commands implemented, but there's like oh hi, and you can check the uptime of my streams. You can see I've been streaming for an hour and 40 minutes or whatever. And it has some like secret features like ping, which will reply with pong or whatever. I don't know. I didn't really finish the bot, but I wrote a couple commands just to like kind of get an idea of how async IO worked. So that's often like an interesting project to work on. Chatbot seems cool. I play out of Warcraft. I could try to get game info. Yeah, that might be something to work on. Okay, so it looks like here, what is this function even doing? Let me like look at the disassembly of this and up. We're gonna break on 14, I guess. Oh, that's gonna get hit 400 times. We're not doing that. Like, it might be easier to just like rewrite this code to not try and build code dynamically, instead build a string of code dynamically. That might be easier. I don't know. But I want to see what these functions actually look like. T.py. Let's grab any old object, set ourselves a breakpoint there. Found, what is it called? Builds? What am I looking for? Object dot rules 0. There's the function. Okay. So Python unfortunately ships with a disassembler called dis, and so you can use dis.dis to look at function objects.
So we have these two function objects here, and Python is a stack-based machine. So let me see if I can turn this into what this looks like in code. So it looks like something that's alright. So we load a constant. So first level of our stack is in the empty string. Then we load another constant, which is this /a/. Then we load a to URL. Then we load a variable called b. This comes from a parameter, I think. Let's see, rule.build. The signature, no. Func. Code dot co arg count. One argument. Co. Where's the arg names? Here's the constants. There's this tuple that we saw earlier. Way earlier. Hey, what's up, David? How's it going? How's your Tuesday? It's late for you. I guess it's not that late. You stay up late. What argument? Which one of these is the one I'm looking for? Names? Var names? Is that what it is? CO var names? B. And dot keyword arguments. Yeah, so B is that positional argument, I think. Harming PvP says, hey man, what are you working on? I'm working on this really boring thing. Where is it? Here we go. I'm working on a memory leak in a web framework called werkzeug, which is German for work stuff. It came up at work today, and I figured I will spend some of my open source time to try and look into it. But this code right here leaks a bunch of memory, and it really shouldn't. This should get freed immediately because nothing is referencing it. So that's what I'm working on. So it's not the most interesting code, but it's certainly something where you might like I'm learning stuff as I'm going along about internals of function objects and how stuff works. Getting there for sure. It's going well. It's going well for me as well. It's really hot in San Mateo for whatever reason. Like yesterday it was a high of like 60-ish, and today it's a high of 90, and so I'm sitting in my room sweating, which is not great. But it I don't know, works. It'll hopefully cool down tonight. Let's see, very cool. A bit over my head. I play around with pandas and matplotlib. Playing with data frames, looking to expand a bit. Cool. That's actually stuff that I know very little about. I also know very little about what I'm hacking on. I mean, I know a little bit about like how function objects are built because I've like poked at them before. But it's gonna be a struggle to implement this code that I want. So I'm trying to like trace through how it works right now and then go from there. So we're looking at this build and build unknown function right now, and how they get built. So Python is a stack-based machine where each function, each opcode either pushes or pops from the stack. And so like this load const puts this string on the stack, this puts another string on the stack, this puts this toURL constant, even though it's not a constant, and this is actually the bug here. Because this isn't a constant, it bypasses the garbage collection machinery, and so that's why these never get freed. Load fast will find a variable that is defined in the function or a parameter and put that onto the stack. So we load b as a variable. Call function, which takes an operand here, will take the number of operands and then the function object and call it. So these two get popped off from the stack. So this is the one argument to the function, and then the one function object. And so then this is return value of toURL b. Then it calls
build string. I don't know what build string does. Let's see, what does build string do? Build string Python opcode. Opcode. Click the right one eventually. Let's see, does this have an example? Build string. Nope. Build string. Oh, I guess it's F strings in Python 3.6. Does it do something else in werkzeug or werkzeug? Gotta pronounce it right. Build string. Return the correct opcodes for building a string from n elements. If the dot join crutch is needed, it must already be immediately below the string elements on the stack. If don't build string. What? If don't build string, build the string. That seemed obvious. Actually, that's probably a bug. Because this one's if not build string. If not, don't build string. Oh. It's probably making a string out of a and then return the return value of 2 URL. Yeah, that was gonna be my guess. And so this number should be the number of arguments that it grabs. So this is equivalent to an F string, which has the first component being /a, and then the second component being 2 URL of b. And so that's what this whole function is doing. Build tuple and then return value. Build tuple 2. So it pops those off and then it returns this and then the F string, I guess. This F string here, let me just copy and paste that. So I think this function returns this. I might have these arguments in the wrong order though, like it might return this instead. Maybe? But I think this first function can be written as def f of b quargs return this guy here. Or at least that is my guess. Actually, I guess I could take this function and compile it and see, compare the bytecode. This 2 URL will be load global instead of load const though, because that's how that's gonna work. Python 3 import this. Okay, so what's different here? Okay, so this load const is in a different place. So that makes me think that my stuff is in the wrong order. Let's try that in the other order then. Okay, so load const, looking good so far. Load. Where does build string come from then? Because it's not F string apparently, because this is F string, which is format value. What's up, Mindful Fox? How's it going? Mr. Debugger. Yeah. Make F strings faster, build string opcode. This seems relevant. What's up, unadmin? Thank you for the follow. Every follow counts. Surprisingly, F was slower than format in almost all the simple cases. It's interesting that they're like arguing about the, in retrospect, they're arguing about the optimization of F strings, but it ended up being that this patch, I think, made F strings faster than all of their string formatting. So it's kind of cool that they got to that. Text debugging you. Yeah. Yeah, I don't know how this comes out, but anyway, we'll pretend like... Oh, there is build string here. Oh, format value called stir on all the thing, or on each of these values. So we can just ignore that, I guess. So it is going through build string, which is good. But format value is not bothered on the left-hand side, so we can ignore that. And then this function should look the same. So load const here, load const here. What is going on here? That seems wrong. Oh, my string is wrong. Was it x.py? Yeah. I put this in string literals. Maybe. Okay. So ignoring the format value calls, we get these two load consts, then we load const this function, although this is going to be load global here because I'm not replicating it exactly. Then we load fast the variable b, we call function 1, this is looking good, format value, which we can ignore, then build string 2, return tuple 2, and then return value. Okay, I think we've replicated the exact function, which is crazy town. But that was the simpler of the two. This function is more complicated. But this is what this looks like. I don't know why there's an empty string at the beginning, but that's okay. But I think we could write this as just like a function, like a function template instead of this like weird code building. Might be a little bit more maintainable. So I think this would be easy to replicate. But anyway, let's try and reassemble this function. So that was the first one. Okay, so now let's start our stack machine again. We start by loading fast the empty string, load const /a, then we get to URL, then we get b. So the first part is still the same. Call function 1, which takes this argument and passes it to b. Return value of this. So we're here now. Load fast keyword arguments. So that was this kwargs. So parameter kwargs. Jump if true or pop 20. So if this is if kwargs, we have eventual code down here. If kwargs jump to 20, which is another load const. Jump if true or pop. So otherwise it removes this from the stack. So if kwargs, then we load URL encode with some a partial URL encode object. Jump to 20. I'm gonna do 20 first, so we'll do this positive branch, and then we'll do after that. Rot 2. What is rot 2? It probably rotates the last two elements. Let's see. Python bytecode rot 2. Still a thing in Python 3? No. Look at the Python 2.4 docs. Maybe they'll be useful. Swaps the top two most stack items. Okay, that seems fine. So it swaps kwargs and partial. And then calls function with 1. So the next thing that we have on the stack, we have the return value of... See, wait, what is it? None. If it's false, then we put the empty string on the top twice. What? So if quargs variable equals URL encode quargs. Otherwise, we put see, partial this gets called with quargs. What the fuck? Otherwise, we put an empty string on the stack. Else, we put an empty string and then we duplicate the top. Opcodes are defined in the dist module docs now. Oh, good. Okay, so then I'll be able to look at what dupe top is. Duplicates the reference on top of the stack. Okay, cool. So we put 2 empty strings on the top of the stack. Then we jump forward to 30, which is here. Build string 4. I don't know why it puts these empty strings twice, but that's fine. So then this would be build string 4. So at this point we have these 4 on the stack. So this is forward to 30. Build string 4, build tuple return. 1, 2, 3, 4. Yeah. Sorry, just filling in this one too. So we load a question mark on here. Rotate 2. Seems like I'm looking at obfuscated code. Okay, so we rotate those. Oh, I see what it's doing now. Okay, this makes sense. So this function looks like see, like question mark and see if quargs q and params equals the question mark and URL encode quargs. Otherwise, q and params equals empty string and empty string. And then return a format string that's /a, then to URL of b, and then q, and then params. I think. So a little bit of a debugging there. Do I have air conditioning? I do not have air conditioning. My approximation of air conditioning is open the windows and turn the fan on at night. So I think this is the disassembled second function, although there's some weird shit going on here that I don't think will be replicated the same. Like this looks like hand-coded ASM. Python 3. So I wouldn't be surprised if this looks kind of different. Especially because this is like... it looks golfed, in my opinion, but that's probably not surprising. Okay, so let's see. This is the same as this here. Load fast, pop jump if false. So they did the opposite. They did pop jump if true. Pop jump if false. It goes to 20. It's here. Okay, so if it's false, it goes here, loads 2 empty strings, assigns them to these variables. But if it's true, we load question mark and URL encode and call the function, and then rotate 2. Which is actually pretty similar to this here. But I did it with unpacking, so it ended up with slightly different code. And then at the end, we get kind of this code up here. Oh, I forgot the empty string. This should be a tuple containing the empty string. And this looks like this code up here with 2 URL, same as here. And then Q and params are the 2 stack values here, which happened to already be on the stack here, so it didn't have to assign any variables. But that looks reasonable, at least doable. Wonder what other crazy stuff happens here though. My goodness. Symbol this in its own buffers because we need to jump over it. So this is the code that's building that question mark thing. Append unknown. Okay, so this actually isn't all that complicated from what I can tell. Needs build string. Okay, so this is if it's an F string or not. So I kind of have 2 ideas on how I could fix this. One is to figure out how the fuck this code works, and like change it to either like reference self for some stuff, for these like where do we have it, for these load consts, because these are not constants, so we can't load them as constants. I could change the code to load those from like self dot something. I would need to add another argument and write some opcodes for that. Which I guess wouldn't be the worst. Or I could change it to a string template, and then it'd be way easier to understand what the code is actually doing than like figuring out what the fuck this does. It's like, no offense to the maintainer, but like if somebody submitted a PR like this to one of my projects, I'd be like, no. there's a trade-off on performance that I'm like not willing to do. And this seems to like violate that. Like I'd probably accept something where like you take a pure Python function and like compile it, but like manually building opcodes to build a function object just does not seem worth it. Is this performance critical stuff? Maybe. Like, apparently it was enough for someone to work on it. What was the other option? 724. No, it's different. I mean, it did make this thing like way faster. I assume it was critical for some point. This looks like black magic. Black magic confirmed. Wow, they actually took almost exactly what I was looking at and explained it in the same way. Is this performance critical stuff? Yes, but introduced a memory leak. Yes, even more sad. It also introduced another bug, which I already hit and they already fixed. It confused the hell out of coverage. This was the minimum test case that I came up with. But it would generate this like weird generated thing, which comes from the function object that they build. Yeah. Which is an awful lot like code you get if you compiled this. Yeah. True. Let's not even talk about generating literal sorts. That's what I was gonna do, because that seems way more sensible than this shenanigans. I'm sure a middle ground is possible. And that sometimes fun has to give way to maintainability. I think maintainability is very important, yes. I've been like, please don't merge. That's what I meant, it's more important than fun. Can afford some complexity to solve those problems. Ugh. Do people actually still use Alexa's top sites as an actual counter? This used to be generated based on Alexa's adware that they convinced people to install. Their like toolbar bullshit. Back when toolbars were a big thing. This conversation is very interesting to me. Yeah, I don't know. I don't necessarily agree with how this got done. This comment has been minimized. I didn't know you could minimize comments. That's new. Politics and open source. I agree, it's interesting. I always love reading these after the fact where it's like, you introduced a big bug, and everyone's like, this looks sketch. And then, surprise, it was! Yes, this is what I was saying. This is what I would do. This would be way easier to understand. It's actually not that hard to generate the source code, I think. And the generated bytecode is more optimized than what Python makes. If you're trying to... like, Python is not a language that does well to optimization. There's no literal syntax for this. Yeah, so you made a hack that leaks memory. Amazing. Well, I don't know. I'm gonna see if I can make something that works equivalent with like just Python 3.6, and then I can try and make it for something else later. That throws away this code, but uses a function generator thing. That's what I'm gonna try and do, and we'll see how it goes. There was the explanation of why build string was there. It avoided a function call, or so they claimed. It does avoid a function call, yeah. Where's the build string? Python has formatted string literals, and the bytecode compiler can use build string opcode just as easily as the join technique. Yeah. Avoids a function call. Yep. You could generate an F string, but then you'd get all the extra stuff F strings have. I mean, we saw these, was it the format value? Which, Python 3 dis. I think format value for strings is a no-op. Format value. Used for implementing formatted literal strings. Pops an optional format spec from the stack, then a required value. Flags is interpreted as follows. Format value 0. The value is formatted as is, so it does literally nothing.
I bet Python could be optimized to just like remove this format value. Like format value 0 should always be a no-op, right? Ops a format spec, optional format spec, then a required value. Formatting is performed using PyObject format, and the result is pushed onto the stack. Oh, I see. So it still calls this function. It's fine how that function is implemented. My guess is there's a short circuit for strings where it just does nothing. Should be great. So here's the here's probably the implementation of format value. Yeah, good guess on my part. Here's the implementation of format value. Format. Oh wait, no, is it PyObject format? So it takes an object and a format spec, or no? If the format spec is not null, and it's not Unicode, then that's an error. If the format spec is null, and it is an empty string... Oh, the format string... What? Oh, if the format spec is null, or the format spec is the empty string, and it is a Unicode object being formatted, it returns. So this is the fast path, which happens for all of the parts. So I think that like optimization is probably not worth it. But anyway, I'm gonna try and build a function object that does exactly this, or exactly what this does, because I don't buy that this is worth it. So where does this actually get here? Compile builder. So it gets compiled with the rule. And what interesting things does the rule have? But then again, I bet if I spend all this time making this string template and then it's slower than the current one, then it probably won't get accepted, even though it fixes the bug. It's an interesting trade-off. Also, I don't think I'm gonna be able to do this in an hour, because I'm probably gonna go to bed at around like 9:15, or at least like wind down my evening, watch some YouTube, and then go to bed. Annoying. At least I understand this code pretty well now. But like this partial here is a problem. Or no, this one isn't a problem. Let's see if I can generate a function that has self, and instead of loading these constants, gets them from self dot something. That's gonna be my goal. So let's see what a function that does that first looks like. Self dot, is it converters 0? Let's fix that. Between the trade-off of fast or no memory leak, it seems like an open source project would choose the latter because of maintenance. Yeah, I agree. But like,
I think the opcode approach and memory leak are not mutually exclusive. Like, I could make this function builder still work. Though I do think like building a string template and evaluating that would be a little bit more maintainable. I don't know. So let's see. Load fast, so we get self, then we load an adder. That part's fine. Load a constant, so we'll need to store a constant still. Binary subscr, that'll get this bit. Then we load B, then we call a function. Okay, so this is going to replace those load constants, I think. So let's try and make that happen. Encode query vars. What is that? Encode query vars. Okay, so I'm just going to change that to self.load query vars. So what is this? uops plus equals self.build op load fast. Do we have any other load fasts? Self.getVar. Need that. And the var is going to be self. Self dot encode query vars. So load fast, then build up load adder. How does that work? Load adder. Name I. Oh, they don't have names here. We'll need to figure that out. Get name. Query vars. To do implement get name using CO names. Okay, so load adder, which is the same as this. Okay, so I think that is the replacement for that one, which is not so bad. GetVar returns a local variable ID for a name, adding it to the pool if not already present. Our only use for local variables is as function arguments. Any variable name that exists before the call to add defaults will become one. Okay, so I think during the initialization we need to make sure that self is first. Initialize self as the first argument. And we're just gonna not do anything with it. So this is the operand portion. So this will be self.converters I think. If I remember right, ind is the index, maybe? We'll try that. Self.build op, which is this one here. Self.converters. Load fast. Self.getVar self. Self.build op load adder. I spelled converters wrong. Converters. Self.build op load const. Self.getConst. So this will be the index, which I think is IND. Crossing our fingers there. And then binary subscript will get us the function. Self.build op binary subscr. I think that'll work. But we need to do our two to-dos about get name. Let's see how get var is implemented. Get name. Return a name. Return a local. Oh. Return an ID for a name, adding it to the name pool. This is used to later populate CO names for looking up attributes. We use this for self.attributes. Why do we call stir here? I don't know, but I'm gonna do the same. Names table, self.names table, x equals self.names, self.names.append x. Okay, so that seems fine. So we need to set that up here. That might work. We'll just run the test, see what happens. I have a breakpoint somewhere. Names tables. I don't know where this breakpoint is. It's right here. It still leaks. Great. So we didn't fix it. Perfect. Well, let's see what we have so far now. We can at least look at these objects. I'm going to change that from map to rule. Just because it's going to be easier for me to play with the object. Hey, we got self.converters here. Oh, I forgot to delete the old code. That's why. Did the original author include the performance test? It'd be interesting to see the before and after if I get that far. There was a little blurb at the top. I don't know if they included the full test though. Test.py. Oh, they did include it. So in theory, I could use this. Leaks memory. But yeah, I can run their test. So in theory, I should be able to see how much slower mine is. Okay, so it still leaks memory. Great. Oh, I forgot to delete their code. That's what I was gonna do. This is the one that I need to get rid of, I think. List out of range. That means they all got collected. Hey. so that satisfies the problem. So let's make one of them referenced and see how my function got built. Hey, yeah. Equals 0. I guess I can just do rule equals rule. I also have to change the calling construct too to make this work. We can at least look at my compiled code though. Let's see, rule dot build. I didn't know memory leaks exist in Python. They're actually pretty easy in Python, especially if you write C Python. Because you can write C code that gets called directly from Python. In fact, the templating language I was showing earlier, it didn't get any development for years, and somebody wrote some code into it that was done during their internship, which is this like super fucking complicated Bloom filter shenanigans thing. Did I fix it or did Evie fix it? I think Evie fixed it. Oh. Just go by A. Monroe on GitHub? No, I don't know. Maybe it was me. But anyway, somebody made a boo-boo in C, and nope, it's not in this history. But they made a mistake in C and caused a giant memory leak on our production website, which brought down everything during a whole company offsite, which was supposed to be a safe no-op change. But that was great. I'm writing a wrapper for an API I need to interact with for some contract work. How the hell do you test-driven dev when working with an API? So what I usually do when I'm doing tests against an API is I will record some sample interactions with the API. So I'll get like request-response pairs. And at least in Python, there's some nice libraries around this. So like there's VCRPy, which I've used before, which allows you to sort of pre-record some HTTP requests and then during your test suite play them back against requests that you make. So like VCRPy is good for that. I put the link in the chat. There's also some, what else have I used? There's like, is it called responses? Python? Yeah, I've used this one before too. Which is a mocking library. This one isn't as powerful, like you have to like know exactly what you're gonna do with whatever APIs in advance. But you can kind of get some stuff working with this. It's very specific to requests, so if you're not using requests, it's not that helpful. And often interacting with APIs requests is not a good idea because it's pretty slow because it does all kinds of cookies and stuff and like pretends to be a browser when really you don't need any of that when you're making API requests. But I've worked with those before. Matt says Betamax is another one. I haven't worked with Betamax, but that one might be a good one. I don't play enough with bytecode. Can you describe what your solution is doing here? Yeah, sure. Let me disassemble it so we can see if it's actually working too. It does fix the memory leak though. The reason it fixes the memory leak is we're no longer loading a constant that isn't a constant. Instead, what we're doing is we're accessing self, which is going to be the rule object itself,
and accesses an element in the converters to get that out. So if we look at like rule dot converters 2, 1. Oh shit, it's a map. Okay, that's easy to fix though. I can just change this from being the number 2 to the variable name. That's not hard. But anyway, what it does is it'll access these as variables instead of trying to store non-constant data in the constants field. It was broken because it was storing non-constants into the constant field, and code objects are for whatever reason excluded from garbage collection in some scenarios. Like it doesn't even check the constants as being references, so it can't know that there's a cycle there to break it. But I'm doing this wrong, so I gotta fix that. Converters. Get constant index, and so this should have been the variable name. Get var name lm. That's just the variable name. Okay, convert. So this should just be get const lm, I think. We should rule.build. Okay, cool. So now we're going into self.converters, and well, I don't know if binary subscript is the right function there. Let's see, def self b self.converters string b. Yep, still the same operand here. My internals knowledge is weak. Mine's not much better. Unfortunately, I've had to like well, actually, I think the most times that I've used the disassembler is to like show something on Stack Overflow. Let's see if we can find one of those. Google, let's see, site, stackoverflow.com, Anthony Sotilli, dis. Is print atomic in Python 3? Oh, this was one of my favorite answers. I spent a lot of time on this. Definitely should not have spent a lot of time on this. Also, oh, I posted it after work, so... Oh wait, Z is in... Oh no, I posted this at work. So I guess I spent work time on this, whoops. This answer assumes C Python implementation details. Python implementation says, okay, whatever. So the question was, is print atomic in Python 3? And I looked at 3 different parts of this. One was the actual implementation of the print function in the built-in module. So the built-in print function. And it calls write object, which drops the global interpreter lock while it writes to streams. And so that alone shows that it's not atomic. Oh wait, I didn't use the disassembler here. Someone else did though. They were apparently corrected. Okay, so maybe that's not a good example. Maybe I didn't though. Huh. Oh yeah, here's an Anthony. Here's an Anthony answer with the disassembly. Variables. Oh, okay. So this is how it changed load fast versus load global. Anyway, that's like most of my use of the disassembler. But I think this works. It's not going to pass the test yet because we're not passing self in, but that'll be the next part. I also need to change the other bit. Oh, we can do the build unknown function. So this is now calling self.encode query variables instead of the other thing, but this doesn't exist yet, so we need to make that happen. But I think this is right. But like we run the test suite, it should fail in a bunch of places. Or at least one place.
Bunch of places. Perfect. It's doing exactly what I expect. It's gonna be like name error or like attribute error on. Oh yeah. Type error missing one positional argument self. So we can fix that though. Let's fix that first. We'll do our actual TD here. Werkzeug routing. Build unknown equals. I think this is how you make a bound method. What is the function that we can do? Test middleware proxy fix. Just make it fail fast. Oh, that fixed it. So I think that fixed one of the tests by binding self to that. Unicode converter object is not callable. Okay, so what did I change here? Up. Okay, so before it was accessing op here, which is apparently not what I expect. Oh, I need to access the like format URL function on there, which is doable. To URL. I think that's what I want. Yeah, let's try that. Okay, so after the binary subscript, we have to get the attribute. Well, past that one test. This is what I expected to see next. Maybe there's already a method that does this. Probably not, though. File match. Builder compiler thing. Compile builder build. Suitable for. No, we don't have one of those yet. So we can make that function. This is the encode query vars that we had from before. Why do you use Nano instead of something like PyCharm? So I used to use IntelliJ, and I used to be pretty good about it. I realized I could be more efficient with it. The biggest problem for me is I spend a lot of time context switching between the terminal and writing code, and between multiple projects, and so that's slower. The biggest thing for me though is I have muscle memory for it, and so it's hard to unlearn that. So I wish I could use a not shitty editor, but unfortunately not the case. Code query vars is what we want. I've been meaning to write up or like record a longer YouTube video that explains that in bigger detail and put it in the description, because I get asked it like almost every stream, but haven't bothered doing that yet. I usually have PyCharm and Zish side by side. Yeah, it makes sense. I could do that. Just don't currently encode query vars self vars return URL encode. Bytecode has the embedded terminal, which is a solid option. Although you'd have to pry Vim out of my cold dead fingers. Yeah, I've used code on stream a couple of times. I set it up because someone in chat was like, "You should use Visual Studio Code," and I was like, "All right, I'll try it." And I tried it, and it was fine. But I don't know, my workflow doesn't bode well for it, or it doesn't fit well with it, I guess. This might pass the test now. Maybe. Fucking sick. There's still stuff to clean up, I think. Code query vars. Sweet, this doesn't get used anymore. And then I guess I will run the performance benchmark and see how that matches up, and write a test that tries to capture my memory leak. Alright, let's get their performance benchmark first. In here somewhere, right? 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 No? It's slower. Well, actually, my computer might be slower. Let's see, so that took this much. Happy that I fixed the memory leak though, because I had no idea what the code was doing this morning. Oh, black, sweet. Oh, this is probably a, whoops. This is probably a refactor that I would do myself. So I'm glad black did it for me. I don't agree with double quotes though, but webs. Not my project. This is my project though, this output here. Yeah, pre-commit. Alright, so let's run this. I usually do best of 5 because that's a pretty good performance benchmark. So like 112 is kind of the best of 5 there. So, no, 6/100ths of a second slower. Seems good enough for me. Double quotes equals Satan. I can agree with that. I actually have a fixer which goes in the opposite direction that I wrote for as part of the open source hooks for pre-commit hooks, because at Yelp there were battles over quotes, and I was like, well, I'm gonna write a fixer that pushes them one way, and you guys won't have a fixer, so GGU. And that pretty much ended the argument. But yeah, there's a double quote string fixer in pre-commit hooks, which does the opposite of black. But yeah, this seems pretty good. I just want to incorporate this test somehow, or not that test, the one that I wrote. This one, which like builds these, garbage collects, and checks this. So let me put this somewhere. Test routing. Test error message. Does the builder get tested? No. Test memory. Test no memory leak from rule builder. See, what issue number did I have? Ooh, 1520. Should just, so PyPy definitely doesn't have a GC module. Does it import error? gc.get objects. What the fuck? It has a GC module? That's not what I remember. Does it not have the get ref counts thing? I think it doesn't have the ref counts thing. Or it doesn't have collect. It does have collect. Is it just like a stub? What? So I know I did garbage collection stuff for Yelp Cheetah, so let's figure out what I did here. Well, maybe I didn't. I thought I wrote a test for this. Oh, I deleted the test because we stopped using the C code. No more C code. Huh. I guess this, oh wait. Oh, sys.refcount was the function. So this should work fine in PyPy. Cool. See if that test passes. One of those tests is real slow and I don't know why. Oh, I need to import GC. Uh, 191 beforehand. So I guess I'll just assert the difference of those then. Oh wait, I'm on master. Right. I'm not on my branch, so it should be broken. Yay, TDD! But I expect it to be like slightly more than 0. Oh, it passes. Okay. Hey, Optimal Bug, thank you for the subscription. Wow. Twitch Prime is good. How's your Tuesday going, I guess? I don't get subscriptions very often, so I don't have a thing that I say for it, but they definitely count. So thank you, bud. PyTest dash durations equals 1. Yeah, that's how I could find this one. Yeah. So Let's actually figure out which one is slow. But I also wanted to make sure that this test passes in PyPy. Durations equals 1, test, running. Test long build. Sounds like a good one. Long build. It makes 10,000 things. So this leaks 10,000 objects until my branch fixes it. Oh no, it doesn't. It just leaks one. Whatever. Close enough. And see, there's trailing white space here, but I don't even care because pre-commit is great. Because it will just fix the white space and it'll reorder the imports and it'll all this stuff. It's great. Did all this magic rewriting for me. Cool. Oh god, what happened here? What the hell happened here? And it got unexpected keyword argument encoding. Oh. What did I run up here? Oh, I ran GitHub compare. Okay, so I have a script that shows me the upstream, but PyPy 3 is, or at least this version of PyPy 3, I haven't upgraded to version 7 yet. This one is based on Python 3.5, which doesn't have, let's see, if I do Python 3.6, you can do subprocess dot check output, I go hi, and you can pass the encoding argument, and then it'll return it as text, whereas if you don't pass the encoding argument, you get bytes. But this is new in Python 3.6, so that's why it crashed. It's all good. What was your QA job like? What is QA exactly? So QA stands for quality assurance, and it can mean a lot of different things depending on the company. The one I was at was super enterprisey, so it's like the least technical side of quality assurance that you can get to. I'll give you a description of like what I was supposed to do over the summer and like how that like kind of translated. My job was supposed to be traversing this. One sec. Thank you, Gamontal, for the follow. Every follow counts. My job was supposed to be clicking through this developer system. The developer system was basically a SQL query builder. And what I was supposed to do is export all of the SQL query configurations to this report format that was supposed to be given to like product managers and external people that were paying the company for this query builder software. And so like what I was supposed to be doing was like clicking through these forms and then like copying all the data out and like putting that into a separate format, but at the same time like making sure that all of the query builders worked correctly. And so like part of my job was doing that data transfer, but the other part was like checking for bugs in this query builder software. But I was like, fuck that, I'm not doing manual work. Like I don't have time for this shit. So I wrote a little web app that basically gave you a drop down for all of the currently built query builders and then spit out a table of all the columns they used and all, like basically all the information I was supposed to collect. I wrote a web app that just did all that for me. And my manager was like, yes, don't show the rest of your team, because it makes their jobs look trivial. But let's get you working on something else. And the funny joke that always went around, or like everyone called this thing that I wrote Anthony's tool, which I don't know, like maybe that name didn't age well, like, but the joke was always that Anthony's tool got more use than the actual product being sold, which may or may not have been true, but I thought it was amusing at the very least. But yeah, then they had me do development work after that. But QA can be a lot different than that. So like Lyft employs a lot of QA, both like quality assurance and quality engineering, which is a little bit different. Quality engineering tends to be more towards like automating, validating. Like our QA group tends to do like release validation or feature validation, or like, here's a build of the app, make sure that this flow continues to work. And so they'll like tap through that and like report bugs and like find issues with stuff and like make sure that like, sanity check stuff before it goes to production. Whereas quality engineering tries to automate some of those workflows. Things like automated testing or automated like build setup, that sort of deal. And Lyft has both of those roles. But that's what that's about. What was the fucking command I was running? Get out of command. I can't remember the name of the script, but I know it from the muscle memory because I type it all the time. But this gives me a link that I can just create a pull request directly. Resolves 1520. This approach is slightly slower than the existing approach, but fixes the memory leak. The core problem of the memory leak is as follows. I'll be using the disassembler to explain this. Hopefully this explanation is somewhat accessible. Winky face. Let's spell this right. So I have some of the original functions here, which is good. Here's an example disassembly from the original functions before I changed them. This rule I'm using throughout is rule/a string of b. This roughly equates to the following function. I'm using Python 3.6. The output is slightly different before that due to f strings, but it's not important for this discussion. Oops, that's the wrong directory. X.py. So this was the function that we built up earlier that represents that. In fact, here's the disassembly of that function. Do I have that somewhere? Probably not. Mostly ignore the... Let me make this bigger so we can see all of what I'm typing out. That's as big as GitHub lets us make it. You must ignore the format value opcodes. Those are used to prepare f strings and are no ops for strings, which is what we're dealing with. Anyway, the issue with the original compiled function is this opcode. Oh, shoot. In particular, this opcode causes coconst to contain these values. Did I ever show that? I did. Perfect. Lucky me, because I didn't want to revert that and have to go back. Particularly, this opcode causes coconst to contain these values. Usually, coconsts should only contain constants. In particular, when the garbage collection machinery of CPython considers function objects, it doesn't consider the constants as potentially collectible, because normally they're just constants. I don't have a citation for this. It's mostly based on what I observed while poking around with GC dot. It doesn't consider them trash. I mean, yeah, that's pretty true. It doesn't consider the constants as potential trash. I like that. Potential trash. Because they're just constants. I don't have a citation for this. It's mostly based on what I observed while poking around with GC dot get referrers with 2 R's. As can be seen here. So I did show that here. Notably, you can see the tuple of the coconsts, but not that a code object refers to it. Yeah, I like the suggestion of trash. That one's pretty good. Okay, so usually it should contain constants, in particular in the garbage collection. Machinery of Python doesn't consider them trash. Because of this, it cannot detect the cycle that's introduced. Map to rule to function object to code object to coconsts tuple to toURL method to Unicode converter to map. Because of this, it cannot detect the cycle that's introduced, and because it doesn't know about that, it can't collect the cycle during cyclical GC. Fix to this is to take the non-constant constants out of coconst and instead refer to the objects directly. My new versions of these functions, I should show the other function as well. Up above. are these opcodes? So that one and this one. What are non-constant constants in this context? This bound method is not a constant, but it's shoved into the constants mapping. So this is supposed to just contain like strings and integers and bytes objects and frozen sets and those sorts of things. But this bound method is not a normal object that shows up in constants. Yeah, it sounds nonsensical to call them non-constant constants. But my new version of these functions adds a self method or self argument to the generated methods and attaches them as bound methods to the rule class on creation. The converters are then looked up on the class as they're called. Here's the replacement disassembly and my interpretation of what that compiles to. So now I gotta generate one of these again. From werkzeug import map and rule. Side effect of constructing a map causes the rule to get compiled. So we have these build and build unknown now. Oops. It knows that they're methods. Rule.build. A little bit longer than before, but that makes sense. Oh, I forgot to explain this second function up here. This roughly equates to the following functions. Build. This one didn't have quarks here. What was my interpretation of that? This here. Does Python have true constants? Yes. Yes, it does. So like, there's few things. There's only a few things in Python that are immutable. Some of them are integers, because 1 plus 2 actually gives you a new integer object. So integers are immutable. Strings are immutable. You technically could mutate them at the C level if you wanted to, but you might as well let the world implode at that point. True, false, and none are true constants. You can't modify them. There was a bug in old Python. Let's see if I can reproduce that bug. What's old enough? Python 2.6? Yeah. Not trusty. We'll go with... was Lucid. That'll download slowly, I guess. Yeah, so true, false, and none are constants. Tuples are also constant, although you can modify them at the C API layer. So they're not truly constant. I guess none of this is truly constant. Like you could piss on memory if you really wanted to. What else is constant in Python? Oh, floats, I guess. Technically a constant. Anything else? Anything else? Anything else? Oh, bytes objects. I think that's it. That's pretty much it. But here's the bug that I want to show you. If you made a class and then made another class which inherited from that original class and then inherited from the type of none, you suddenly get this object that looks like none, but is not none. So it's kind of none-like, but not really. This is an error in newer versions, and like this is what the error looks like. they just forgot to special, or like didn't properly special case multi-inheritance. But this is the new error that you get here. Oh, Frozen Set. Yeah, I forgot about Frozen Set. Forgot about Frozen Set. Frozen Set's a good class. I wish they would have a true Frozen Dict, but alas, there's no such thing. So Frozen Sets are technically immutable as well. In any language, if you avoid the language and force C/asm, you can avoid everything in the end. Yeah, that's true. Unless there's like mprotect to like protect the memory regions. You could technically make immutable pages that way, but I don't think anyone does that. But yeah, fun little tiny bug in old versions of Python. But yeah, let's continue explaining this. Build unknown. Yeah, so this is the build unknown implementation. Here's the replacement disassembly icon and my interpretation of what that compiles to. So I'm just going to take these functions and paste them down below and adjust them. Oh, I should put a comment on those 2 lines where the constants come from. To URL is loaded from coconst. What's up, CodeVal or CodeVal? That's a cool name. Thank you for the follow. Every follow counts. Let's see. URL encode is loaded from coconst. To URL is loaded from coconst. Okay, so this should be self.converters. F string with single quotes, this is double quotes. Self dot, what did I call it here? Encode query vars. Yeah, so that's the, ooh, what is that emoji? Oh, I see. I'm in dark mode, so I can't see it, but it's deadmau5. Deadmau5, as you're supposed to pronounce it, right? So we basically replaced the illegal coconst lookup with lookups on self. Running the perf benchmark from the original PR, this seems to make these ever so slightly slower. Am I doing reverse engineering? Well, I had to. It wasn't my intention, but oh, I have an L. You're right. Thank you for catching my. I was guessing deadmau4 was taken. Yeah, so I didn't intend to do reverse engineering, but this caused a memory leak, and the way this is built is by jamming together function objects by manually assembling the bytecode of those, and so I had to manually disassemble to figure out what the hell's going on, and then write a replacement for it. This should be... Does that make a line? It does. Perfect. So then I need to run the perf benchmarks. Let's see, git branch. 1, 2, 3, 4, 5. Best of 5. I used best of 5 here. Git checkout. One, 2, 3, 4, 5. Oh, that one was really slow.
the same number. That's not what I wanted. Oh boy. Oh, because I did the wrong copy. I wanted Control C. I did Control Shift C. So 4% slower. That's might as well be error noise. 4% slower. Okay, let's look at this write-up and see if it makes any damn sense. Let's see, resolves 1520. Approach is slightly slower than the existing approach, but fixes the memory leak. The core problem with the memory leak is as follows. I'll be using the disassembler to explain this. Hopefully this explanation is somewhat accessible. Winky face, because it's deep dark magic. Here's an example disassembly from the original functions before I change them. The rule I'm using throughout is this rule here, which has this argument. Yeah. So we disassembled the build function and the build unknown function. I thought this channel was about coding, not novel writing. Yeah. Well, rip guys. So here's the two disassemblies. Let's see, this roughly translates to the following functions. I'm using Python 3.6. The output is slightly different before that due to f strings, but it's not important for this discussion. So the build function is this tuple and this f string. And I mentioned here that toURL is loaded from consts. And then build unknown uses this. In fact, here's the... Oh, I forgot to reverse disassemble this one. Oh, gotta fix that. Got to fix that. Here's the... Where is that? Here's the disassembly of those functions. I guess I gotta disassemble those then. We don't want to copy that. This. Okay, disassembly of those two functions. This one is almost identical, this one not so much because code's moved around, but whatever. Anyway, the issue with the original compiled functions are these opcodes, which load these consts. In particular, this opcode causes coconst to contain these values. It's Unicode converter object. Usually, coconst should only contain constants. In particular, when the garbage collection machinery of CPython considers function objects, it doesn't consider the constants as potential trash. Thank you, chat. Because normally they're just constants. I don't have a citation for this. It's mostly based on what I observed while poking around with gc.getReferrers with 2 R's, as can be seen in that comment. Notably, you can see the tuple of the coconsts, but not that a code object refers to it. Because of this, it cannot detect the cycle that's introduced. Map, rule, code object, coconsts tuple to URL method, Unicode converter to map. And because it doesn't know about that, it can't collect the cycle during cyclical GC. The fix to this is to take the non-constant constants out of coconsts and instead refer to these objects directly. My new versions of these functions add a self-argument to the generated methods and attaches them as bound methods to the rule class on creation. The converters are then looked up on the class as they're called. Here's the replacement disassembly and my interpretation of what that compiles to. So this is kind of the... This code right here is the changed, what used to be a load const, but now it's self.converters bracket b bracket. Dot to URL, so a little bit more. And then this was the other part down here. This used to be a load const, but now it's self.encode query parameter or encode query vars. So we can see that here and here. This is a great bedtime story. Yeah. No, this is the riveting conclusion of 3 hours of streaming. Yeah, there we go. There's the real answer. So we basically replaced the illegal coconsts lookup with lookups on self. Running the perf benchmark from the original PR, this seems to make these ever so slightly slower. I use best of 5 here. So 4% slower. Might as well be error noise, right? Right? Hopefully, right? This is probably the most magical part of this PR. Which is just binding these methods to self. This I happen to know... Oh, when did I use this? I think I used this in a test runner that I worked on. Because of course Yelp had to write their own Python test runner. For whatever reason. When I ported it to Python 3, I had to change this. Yeah, so in fact here it is right there. Oh wait, no, this is the one. Oh, but I used type self. Does this work in Python 2? Shit. What does double under get? So double under get is for descriptor. This is like super advanced shit. So descriptor objects is how attribute lookup works on Python. So let's see, I have an example that explains this. Because I explained this to somebody at PyCon in 2015, and she kind of got what I was talking about, but at the same time, I was like, it's kind of blowing my mind at the same point. Okay, here we go. So there are two types of descriptors. There are data descriptors and non-data descriptors. And when Python looks up an attribute on a class, so say or on an instance, so say I have an instance of bar and I do bar.x, it goes through this descriptor here, which we'll call, let's see, data descriptor. It'll call double under get on that descriptor, which passes in object and owner. I think owner is the class and object is the instance. I don't really remember. But this get is how that works. And so that's how, for method objects in Python, that's how self gets injected as the first argument for the functions. So what it actually does is it takes this obj and feeds it as the first positional argument when you call a function. So that's why you get confusing messages like class C def f self x. Actually, we'll just make it take no arguments. If I do c.f and then pass it one argument, it'll be like, it expected one positional argument, but two were given. And so what's actually happening here is the method descriptor portion is injecting this instance of c as the self argument, and then this one is the second argument that's given, so that's why that's an error. But that's kind of how that works. For bracket bracket, like Everx said, that one's actually get item is the callback. But you were close. But the only reason I know about descriptors is because I had to implement some shit for that. Also, descriptors are useful for implementing a cached property. Let's see if I can do it from memory. Let's see, object def get self obj owner. Oh fuck, I did it wrong already. So, wait, how does it work? Cache property object init self func set adder obj func dot name self.func obj. Oh wait, is it? I think it's this. Return adder obj func.name. So you can make a class def f, or wait, cache property. And then an instance of that. So if we do c.f, fuck. Ah, this should have been self.func. No! Damn it. Anyway, if I would have done self.func, I'll just show it.
Copy this to a file and do it that way. t2.py. We'll simplify it a little bit too, so we don't have to get out of this. So what should happen here is the first run of c.f should cause this print to happen, and then we should print 4. But the second run of c.f shouldn't happen because this get should have overwritten itself on the object. If I did this right. It's been a while. I guess I'm gonna write this and run it over here. t2.py. Func is not defined. I fucked it up again. Self.func. Here we go. F is a method, so you're missing parentheses. Oh, well so I'm trying to emulate property here, so that's why it's showing the double under get. So it's actually intentionally not supposed to have parentheses here, because this is essentially how property works. In fact, like if I were to implement my own crappy version of property, it would look almost the same as this, except we would just return self.func so if we do like my property def g, return 5 here. Print. Yeah, so this did exactly what I expected. I was more focused on the cache part. It's 12:30 my time, so I'm brain dead. Yeah, that's fair. Yeah, the idea here is that like you only compute this property once, and so if you look over here, like the first time we ran c.f, it caused this as a side effect, but then after that we just retrieved the value without rerunning that. And this is like a 5-line version of the standard lib property decorator. Although in Python it's implemented in C, so it's way faster than this like crappy pure Python one. But it's useful for demonstrating the idea here. What was I doing? Did I press play? Did I press submit on this PR? Did I actually do that? Or did I get distracted? I did not. I did not press this button. Oh, I was looking over the code, right. Yeah, so I think this is the most like confusing part of this, but that's fine. Oh, I was gonna do something in Python too, yes. I was gonna make sure that my... Thank you for the reminder. PyTest requests. I was gonna make sure the tests still pass in Python 2, because I was doing something slightly different there. Please pass? Okay, I think they're passing. I think we're good. I don't know what that none does there, but... and this says actually Python 2. Okay, cool. I don't know why this is none here, but... is the type here? I think it's supposed to be type self, but I don't know what that changes. And I don't particularly care, as long as it works, I guess. But yeah, then I had to add these names here. I had to add self as an argument. Basically copy pasted this function from there. Got rid of encode query vars. This new thing here. Oh, this should not be I. Damn it. Werkzeug. Routing. What? Do I have the wrong file? What file is this? I've been working in it all day. You'd think I would know. Routing. Oh, I'm on master. Right.
What module do you use for testing? I usually use PyTest. I'm also a maintainer of PyTest, so I have bias. Self-taught converters. Hard name. Add dash u git commit amend. He has bias. It's rare to see someone using Nano as a code editor. Yep. Yeah. You probably won't see too many people using Nano as a code editor. It's a bit of a rarity. That said, I did find someone else who uses Nano as a code editor and uses it so much that she blogged about it. Rachel by the Bay Nano. Is that not what her? Is that not what her blog is called? Oh, I'm never gonna find this. Programming blog. I guess I could just look at my DMs with her. Let's see. Yeah, it is Rachel by the Bay. I wasn't wrong. But she blogged about using Nano. I'm pretty sure Nano blog would work. Oh yeah, probably Nano blog. Nope. Unfortunately not. Nano blog, Rachel. Rachel's Nano blog, nope. Anyway, I found the article, but yeah, she uses Nano as well. And she actually sits 2 seats away from me at work, which is pretty cool. But anyway, I'm not the only one. You're the only 2 people that use Nano. Yeah, pretty much. So fix that little bit of code while doing a self-code review. So we fixed, where is it? We fixed this, but I'm not gonna refresh. Oh, I did to do is to done. So this is why it's good to review your own code, because sometimes you catch stuff before you embarrass yourself in front of other people. We got rid of this because it's no longer used. Got rid of that there more because it's no longer used, and names is new. And then I wrote my GC test. Looks good. All right, that concludes this 3 hours of. Oh dear God, what is this? But I'm happy with what we came up with. Anyway, that's gonna conclude the stream for today. I'll do my quick spiel. The first thing is, if you missed any part of the stream, I put them up on YouTube afterwards. That's GitHub, not YouTube. What am I doing? My YouTube is Anthony Writes Code, where I upload my previous streams. I also have some other educational content on there, but I don't know. I don't often. It's so much work to put up new presentations, and it's really easy to stream and put up streams. So it's mostly been dominated by that recently. Like I looked at the time commitment, and it takes like almost 12 hours of prep for like 15 minutes of video, and that's just like that time trade-off is just super not worth it. So I don't do that. But anyway, if you want to catch previous streams, they're up on YouTube. I usually stream, or my regular stream schedule is Saturdays at 1 Pacific time. Sometimes during the week I'll stream haphazardly at like 6 Pacific time, but I don't know, those are unscheduled. But I usually announce them on Twitter an hour before I do that, and that's twitter.com/codewithanthony. I don't have great brand synergy, so unfortunately this name doesn't match my Twitch and YouTube, but anyway, they're close enough. And other than that, follow me on Twitch, and that's all I've got for today. I'm gonna go see if somebody else is streaming, and we'll raid them. But thank you all for stopping by.